To the human eye, a skyscraper appears entirely still, but beneath the surface, thousands of tons of concrete and steel are in continuous, active motion. As temperatures rise throughout the day, these materials absorb heat and expand. When night falls, they contract. This cycle exerts massive internal pressure on rigid frameworks. Simultaneously, lateral wind loads push against the upper floors, while microtremors radiate up from the foundation into the base of the structure. A building is a dynamic system. Without a mechanism to release this stored kinetic energy, the rigid materials will inevitably tear themselves apart. When kinetic forces have nowhere to go, the stress fractures foundation slabs and compromises exterior facades. To survive, structures rely on an engineered gap, the expansion joint. It absorbs kinetic energy, allowing parts of the building to move independently while remaining safely connected. Yet, this critical threshold is routinely treated as an afterthought in the construction process, often filled with off-the-shelf, generic components. Saving a fraction of a percent on a cheap joint directly leads to millions of dollars in damage when that component eventually ruptures under strain. A failed seal breaches the entire building envelope. Water penetrates the gap, flooding internal corridors and degrading subterranean rebar. When these small gaps fail, the resulting intrusion of water and fire can cut decades off the service life of an otherwise sound multi-million-dollar structure. MK Dewan and Dseal Solutions design specialized engineering countermeasures for chronic structural failure. Dseal treats expansion joints as custom-engineered systems, tailoring material selection to the specific kinetic profile of a project. This structural foundation uses thick, dual-chambered extrusions and heavy-duty ASTM 6063 T6 aluminum anchors to lock into the concrete. Between them, a dual-extrusion santoprene rubber seal acts as cartilage, compressing and expanding as plates overlap during thermal shifts, retaining its physical memory. Pairing a rigid aluminum anchor with a highly flexible elastomeric core creates a system capable of outlasting the building's natural movement cycles. Structural gaps don't just push and pull on one plane. During an event, they experience violent shear and vertical shifting. To handle this, Dseal's centering bar and spring assembly stretches and twists in 3 dimensions, absorbing the shock before rapidly repositioning. Beneath the visible surface, these systems contain hidden layers of redundancy. An integral moisture barrier membrane ensures absolute water tightness, even if the top plate is submerged. Below that lies a high-purity ceramic fiber blanket. This secondary fire barrier is rated to withstand 2 full hours of direct flame, preventing a localized fire from traveling through the floor slabs. These systems integrate shielding and flexibility, maintaining the building's thermal, fire, and moisture barriers through even the most extreme movement cycles. Different architectural environments subject these gaps to radically different load-bearing, chemical, and aesthetic threats. Here, this flush, wide-ribbed elastomeric profile is leveled perfectly with the adjacent floor tiles. Designed for hospitals, it eliminates stretcher vibration while maintaining a hygienic, easy-to-clean seal. For commercial airports and retail centers, this wide, multi-ribbed aluminum cover bridges large voids between slabs. It integrates cleanly with high-end marble finishes while surviving massive daily foot traffic. Heavy infrastructure requires a different approach. Looking at the relationship between the black multi-layered seal and the structural side frames, this system is engineered to endure the punishing, continuous rolling weight of vehicle transit and forklift loads. In extreme exterior applications like railway bridges, Dseal utilizes this unique, hollow, arched omega shape. Made of chloroprene rubber, it handles high water pressure combined with massive multi-directional movements. Survival across these distinct environments requires matching the exact material engineering profile directly to the specific environmental threat. If an expansion joint is considered only after the structural concrete is poured, it is already too late. The structural footprint is final. This is why Dseal acts as a pre-construction partner. They provide vital design assistance and precise specification development directly at the blueprint stage, before the first yard of concrete is ordered. They provide on-site installation guidance to guarantee that their factory-engineered tolerances are not compromised by poor execution in the field. Purchasing structural components from a transactional vendor creates inherent blind spots in the construction process. An end-to-end engineering partnership with MK Dewan's team removes that friction. Specifying Dseal serves as an active defense against physical degradation. It ensures that the engineering calculations on the blueprint translate into long-term structural survival.